All right, let's talk about acing your next coding interview. Today, we're going to do something a bit different. Think of this as your own personal coaching session. We're tackling the one topic you are absolutely guaranteed to face, the array. We're going to walk through the exact questions an interviewer will throw at you, pretty much in the order they'll ask them, so you can walk in there feeling totally prepared.
So what's the number one data structure you're going to get grilled on? It's a rhetorical question, of course, because it's the array. Hands down. And you know why? Because it's the bedrock. It's the fundamental building block for so many other more complex data structures. If you can nail the array questions, you're telling that interviewer, hey, I've got my fundamentals locked down.
Okay, so this is almost always where the interview kicks off. The interviewer leans back, looks at you, and says, "So, tell me, what is an array?" Seems simple, right? But believe me, your answer here sets the stage for everything that follows. So let's nail this response. This right here, this is your golden answer. It's short, it's sweet, and it's packed with the two key words they're listening for, sequence and contiguous. Seriously, those two words are key. It shows you get that an array isn't just some jumbled bag of stuff. It's an orderly line of items all sitting right next to each other in memory. And you know the best way to back up that perfect definition? Show them. You immediately follow up with a concrete example. On the whiteboard, you jot down something just like this. You're basically saying, look, I'm setting aside a chunk of memory for an array I'm calling A. It's built to hold exactly 10 things, and every single one of those things has to be a double. Now, if you really want to impress them, you don't just stop at the definition. You hit them with these key properties. Think of them as your expert follow-ups. You can mention that all elements have to be the same type, which is huge for how memory gets planned out. You bring up that contiguous memory again, because that's the secret to its speed. You point out its biggest weakness, that it has a fixed size. And then you drop that you know it uses zero-based indexing. Boom, you've just shown you really know your stuff. Okay, you've absolutely crushed the definition. What's next? Well, the interviewer is going to pivot. The next question is almost always going to be about performance. They're testing you now. Do you just know what it is, or do you know how it behaves? Now, before you start spitting out answers, you got to make sure you're speaking their language. And in the world of interviews, that language is big O notation. Don't let the name scare you. All it is a fancy way to talk about how an algorithm slows down as you throw more data at it. So when they ask, how does it perform? What they're really asking is, what's this big O? And this table, this is everything. This is the heart of your answer, because it shows the big trade-off with arrays, clear as day. Look at access. It's O of 1, or constant time. That means getting the 5th item or the 5 millionth item takes the exact same super fast amount of time. It's the array's superpower. But then look at everything else. Search, insertion, deletion. They're all O of n, linear time. That means the bigger the array gets, the slower these operations become. It's a deal with the devil, really. But wait, a great candidate doesn't just state the what. They explain the why. So why is that random access O of 1? How is it so fast? Well, it all comes back to that magic word, contiguous. Because all the elements live right next to each other in memory, the computer can do some simple math. It knows the starting address, it knows how big each house is, so to find the 100th house, it just calculates the address. No need to go door to door. It just jumps right there. That's the secret sauce. All right, theory portion passed. You've proven you know the concepts. So now the interviewer is going to switch it up. They're going to say, awesome, let's solve a problem. This is where the rubber meets the road. Can you actually apply what you know? And they'll probably start you off with a softball, something like this. This isn't designed to trick you. Seriously. What they're looking for is your process. How do you break down a problem? Is your code clean? Can you write a basic loop? It's all about checking the fundamentals. Okay, now listen up, because this is probably the most important tip I can give you. Before you write a single line of code, you talk. You walk them through your game plan step by step, just like this. It's not optional. Honestly, explaining how you're going to solve it is often more valuable to the interviewer than the code itself. They want to see your brain at work. So you've written the code, it works, everyone's happy. A good interviewer isn't done yet. They're going to push for a deeper level of understanding. They're trying to see if you can think like an engineer. Not just how to use a tool, but when and why to use it, and just as important, when not to. And really, it all boils down to this. The good? You get that lightning-fast O1 access, and they're super efficient with memory. Can't beat it. The bad? That fixed size is a real pain. You have to know how big it'll be ahead of time. And if you need to add or delete stuff a lot, that ON cost to shuffle everything around, it's just a performance killer. Now let's talk about the #1 classic, biggest mistake you can make with an array. The interviewer might phrase it like, what's the biggest gotcha? And this is it. Right here, your answer has to be about trying to access an index that's, well, not there. Going off the reservation, so to speak.
And for bonus points, you need to name the error. If you're in a Java interview, you say it loud and clear, array index out of bounds exception. Saying the actual name of the exception is a huge signal. It tells the interviewer, I've been in the trenches. I've seen this error, I've fixed this error, I've done more than just read about it.
Phew. Okay, we have covered a ton of ground here. The definition, the performance, how to code a solution, the trade-offs. So let's wrap it all up. Let's put this into a final checklist of things you need to have ready to go the moment you step into that room.
This right here, this is your game plan. If you can hit all 5 of these points, you're golden. Define it clearly, state its performance, O of N access is its superpower, O of N updates are its kryptonite, explain why it's fast, that contiguous memory, know the big risk, that array index out of bounds exception, and finally, summarize the trade-off. It's perfect for stable data you need to look up fast, terrible for lists that are always changing. You do all that, that's an A+ answer, my friend.
So I'm going to leave you with one last thing to chew on. And this is the kind of question that separates the good candidates from the great ones. When is an array actively the wrong tool for the job? Seriously, think about that. Because the answer to that question is what opens the door to all the other data structures you need to know, like linked lists or hash maps. And that's exactly where the interview is headed next. Good luck out there.